Okay, perfect. I think we're live. Okay. Should be doing good here. Okay, perfect. Hello everyone. Hey, I hope you're doing really well today. Today what I wanted to do is I wanted to check this paper that I've been reading. I think it was like 3 weeks ago. No, 2 weeks ago. I was reading this 2 weeks ago, and it was actually pretty simple and pretty interesting for two main reasons. Because of the technique that they use, that is like ridiculously simple, but like produce good result. And second, because it showed you something interesting about reinforcement learning in LLMs, which I think is always good to have in your back pocket. So yeah, these two things, pretty cool. And I'll be showing it to you live. Remember the format of this stuff. It's really about, wait a second, did I mess this up? No, I think it should be good. Wait a second. Where's the chat? Okay. Hi, HICRA. There's a chat on YouTube, but I don't see the chat on. I don't see the chat on Twitter. Okay. Hey, Darsh, how are you? Okay, we're good. Sorry for that. Yeah. So what I was saying is that it teaches you something interesting about just generally reasoning in LLMs, right? Which is pretty good. Yeah, Vid, I'm doing good. My family is doing good. I think my little one is starting to get sick, but overall it's pretty swell. Yeah. Hi, Faima. Sent you an email, by the way. Check it out. So remember the format of this thing? Yes, this is Gatorade. The format of this thing is that I'm gonna talk about this, but this is not important, right? If you have any question, deep learning, AI related, just shoot it to me, and we'll go through it. The paper is this one, right? So actually, it's a nice read. I think it was really well written. I'm gonna give it to you, folks. It's in the description on YouTube. But like, it's a really nice paper, well written. And not too long, and yeah, it has some connection with the HRM paper. I thought it was the same guys that wrote the HRM and this, but it's not actually the same guys. And because like you have the brain here exactly at the same spot as the other paper, so it was like, yeah, it's a continuation, but it's not. Like it's another team. But there's a high connection with HRM. So you can follow along if you want. Thanks Darsh for the well wishes. You can follow along if you want, but I'll just run through it, right, and then we'll be able to check it out. But before that, I always find funny when I can do that. Now this is a big boy live stream, so we have some sponsors. Actually, we just have one, but they're awesome. So our sponsor for today is Scrimba. Yeah. So if you saw the last two stream, it's the same sponsor. But really cool company, right? Like what they do is that they are kind of a learning platform that is more interactive than just like watching a video. Historically, they were more into the front end stuff, but now they included more of the full stack stuff, which include directly some AI. So you have like some stuff over here. So all the classes, some of them are free, some of them are not free. You have to be in the pro subscription. But like it's more oriented toward people that want to learn like the practical AI topic, not like what I'm teaching right now, which is like the theoretical topic. But I mean, like if you want to build an application, this is fantastic. They have this full stack developer path with like 100 hours worth of content. And if you look here, you have the AI engineering section, right? And then like it's really the basics of AI engineering, which doesn't show you literally like how to train a model. You can show you a bit to how to fine tune it. You're not training a model from scratch here. It's like using these foundational model in order to wrestle together an application, right? And what I like about this is that let's look at maybe let's look at this one maybe. No, this one's good. Yeah. So like the cool thing is I just like the UI, right? That's one thing I love about this company is that the UI is there, and then there's gonna be a video, right? And then blah blah blah, and then this thing is actually you can stop, you can pause it, right? And you can start to kind of like mess around on the stuff. Like it's an interactive. It's an interactive kind of canvas with the teacher, right? And then once you're done, you can discard that and run it through. And at some point when it stopped, it actually stopped with the challenge that you have to do, and then you code it, right? And then like just after that, it will show you how to do it, and it will actually code it for you. It's kind of like having somebody that is like coding along with you. Anyway, man, like pretty cool stuff. You can check out the link in the description, and otherwise you can just go straight there and check this out in more depth if you want to. Huh? We have with sponsor, the rate at which you grew in X is why. Why is not the same here? I have no clue. I have no clue why YouTube. I think YouTube is a different demographic or something like that. But I don't mind. Like everybody on YouTube is pretty chill. I much prefer having like concentrated amount of people that are like very interested about like learning this type of weird stuff versus just like having everybody in the whole world as a subscriber. Hey Jürgen, hope you're doing great. Cool. So without further ado, let's actually start. I made this nice little slide over there, right? I can actually share it afterward if you want to. Yeah, actually I can share it. I can share it right now, right? Yeah, publish this file. Copy link. Yoo-hoo. I'm already Sushi. I'm already posting this on YouTube. So if you check out my channel, you can see we're live over there. You can go into the Tilra board actually and just like start to look around as I'm going in there. I think I shared it into just the viewer mode. Okay, cool. So I'll show you the overview of what's up, and then we're gonna go into like the big ideas of like what they're saying, why it's even like what they even conceived this idea of reasoning, hierarchical reasoning in LLMs. We're gonna check out how they did their work, how they like tuned up GRPO into, I think they're called HICRA, right? And then like the learning dynamic that are pretty interesting. Why the hell this is happening here? Yeah, and then the conclusion, we're gonna go through it. The paper is pretty easy. It's not a difficult paper to understand. So yeah. Okay, so if you saw hierarchical reasoning, you might say to yourself, this looks suspiciously like the HRM, which is not too far, right? The HRM is just like breathing down its neck. You see here, like they did the same thing. There's the brain here, and then here there's the same thing. There's I don't know if they talk together or something. They must have talked together, right? And they're like, yeah, let's push the reasoning, the hierarchical reasoning propaganda. And like the guy that made the HRM, I think one of the main one, I think it was Wang. He posted about this paper, and he was like, "Ha! Told you, I told you I was right." Yeah. And the funny thing is that if you saw the HRM thing, everything about the hierarchical reasoning was kind of debunked, right? By not really debunked, but like it was not as important as the rest. So fairly funny that like now we're gonna dive a bit more into hierarchical reasoning. For the folks just joining on Twitter, I'm not talking about DeepSeek. I'm talking about the hierarchical reasoning in LLMs. We're gonna get to DeepSeek in the change in attention they did a bit later on in a week. Okay, cool, perfect. So like that's a paper, but I summarize it here. On Twitter pretty succinctly. So like what they did is that they have a prior idea that like good reasoning is about like strategic planning, right? It's not just about like doing little stuff. It's like strategy, right? And then the core idea of the methodology is that they're gonna take the tokens and then they're gonna classify them into strategy token and then operation token, both of them, right? And then they're gonna change GRPO So it's like the algorithm that will make that will teach the model to how to reason, roughly speaking, right? That's from DeepSeek. So Biswaji, don't be sad. There's still the ghost of DeepSeek in this overview. And then they get to train a bunch of models. So they train like 4 family, one that sucks and other ones that are like a bit better. So the one that sucks is Llama. And the model that had a good operational base, however that means, were super duper good. That's kind of the idea. And then they get better than GRPO in the average, which is pretty interesting. So that's it. Like everything in the paper is basically just that. Somebody says, I'm not good at English. How do you think I can interpret and read articles faster and more effectively? Just read them slower. I'm not even joking. Like the question is, if English is not like your first language, right? How can you interpret and read the article faster and more effectively? The thing is, like, you don't have to do that. Like you like it's not about the necessarily language. If you think about it, like most of these people are not even like first generation English speaker, right? They may be Chinese and then they write it in English. So it doesn't matter. Like the language in the text is not like some insane prose that you have to decipher. It's just like the basic fact, and it's just like logical fact one after the other. The issue is usually because the language, it has a lot of like meaning that you have to search, and it's like field specific meaning, or it's math or code, right? So in all of these things, reading it faster doesn't make any sense. You just have to read slower and then just figure out what each of this thing means, and then you'll be able to get it. Like some piece of math, I can stay there for like a full day just looking at it and then try to decipher what every bit is doing. And some I just kind of blaze through it because I've seen it enough, right? That's the other thing, is that to read faster these paper, you just have to read more of these paper, because the core of it doesn't change. It's the same thing. If you look at the introduction of every RL paper, it's the same thing. And then if you go down, it's just like the method that changed and the result and what it means and stuff. So to read it faster, you just have also to just read more of them. But that's it. There's no silver bullet here. Chris says, it is definitely about the topic, but understanding the semantic of the word is important. Yeah. And like some words are used differently in different fields, so you kind of get like, you need to get the lingo of the field. Okay, so we're starting up. Basically what they're saying here is that like in the brain, this is like a poor depiction of the brain. In the brain, like you're gonna say something like this: hey, I have this problem, and then there's a bunch of branching that you're gonna do in your cortex, right? You're gonna say something like, hey, first I need to understand this, let's look at that, I noticed this, and then, oh, well, I messed up, and then you backtrack here and stuff like that. Or you go into another branch and say like, alternatively, we could do this, and then like you're gonna branch here, and then there's gonna say, I'm not sure, and at the end of the day, like you're gonna get to the proper final answer here, right? So it's like these things, and then you have these nodes that are like meaning something. I noticed that, wait, but I'm not sure, aha, like that type of stuff, right? This is their semantic big high level planning tokens. And then you have the low level execution one, which like it's just everything else. Like it's not there's not a specific word for it. Like it's just like everything else is low level execution, and the user request is just here. It sucks as a diagram because none of this is happening. Like the final answer is like popping out of your occipital lobe, poof, like from your visual cortex, whatever. Like most of the processing will happen here, right? On this, maybe language a bit over here, some spatial kind of related thing, but like nothing in the visual. Like they should have flipped this and then just put that thing somewhere here, or like on the language section. But this is just like a neuroscience nitpick. Okay, and the main result is this: is that there's like, if you separate the tokens into like execution ones and then strategy one, you're gonna see stuff, right, that is different. And then this dynamic was hidden in the past. That's what they're saying, right? By the way, this is a September paper, so like it's like new stuff. So if you look at the entropy, so how much different things are roughly, you see that the execution token, they shrink in entropy really early, and then like they kind of stay low. And if you take all the token together, you're gonna see this, the same curve, right? And what you might say is that like nothing is changing now. There's nothing that is learned, so you can abort the learning at this point. But if you look at the accuracy, like it stay better and better as time goes on, even if like the entropy doesn't change in the execution token. But if you look at the planning token, right, the entropy increase actually has a opposite kind of flow than the execution token. And we're gonna see in a minute how they define planning versus execution. But like that's the idea. So basically what they're saying, right, is that at the beginning when you're doing GRPO and stuff for your RL, the model is actually wait a second. What the heck is that? Oh, sorry. I was actually listening to the live, so I had like some feedback. Yep, so what I was saying here is that the model is actually trying to learn these low-level skills first, and once they master it, so like this doesn't change anymore, like there's a consolidation of them, then it's learning like the semantic planning token, right, which will help it kind of anchor its thought process across multiple like reasoning steps. That's the gist of it, right? And then like this, if you use that and then you take GRPO and then you bias it toward doing the planning token more, you will have better performance. That's that. That's the whole thing. So this is what they're saying is that demonstrating the critical performance bottleneck, shifting from procedural skill to strategic. So you have to do both. And then this presuppose that if you already have a good operational base, it means that it will benefit even more from HICRA than anything else. And then HICRA is the thing that I'm talking about, like the GRPO that is modified. And then it demonstrates that specialized QA assignment targeting this strategic bottleneck yield more effective training. So like good stuff, right? And then what they're saying here is that a likely university of this reasoning hierarchy in complex reasoning task. So it's saying secretly like that there is an HRM hidden into this mass of weights, and then we love HRM, everybody. So that's the core idea. Any question before we go into kind of the basis about like why even hierarchy is important here? Okay, doing good. So the big brain idea is that the good reasoning has two parts, right? There's the high level strategy stuff, and then there's a low level operation, right? And you can't have like just one or the other, right? We have a question. Is this still biased to length? So what do you mean by biased to length? So that the length increase? The length does increase here. I think the reasoning is that the planning token will like create this increase in length specifically because they need to like anchor into multiple steps the low level operation. The GRPO that they're using is another version. Is like, wait a second, it's this one they're using. Wait a second. I saw it not long ago. Jeez. Oh boy. No, I don't want that. Sorry for this. So yeah, what I was saying is that okay, it's GRPO clip higher. That's what they're using. Okay, so the big idea is that like there's a high level strategy and then there's low level ups in the brain, right? Generally in the brain, and then we can see that in multiple facets, right? So if you see that in the hippocampus of rats, actually I think it's mice, you see this coupling between two like a frequency of information. You see like the low level frequency that are like going around and then doing like the small task, and then you see the higher level frequency, which is the low gamma subband. And if you like make a specific task for the mice, right, that will like require them to kind of look at the context and stuff like that, and you literally have a wire like straight in their brain like this, that and record, you'll be able to see a coupling that is happening during learning between the phase frequency in theta, right? So theta band is like from 4 to 10 hertz, so it's like fairly a lower frequency, and then you're going to see the amplitude frequency here at the low level gamma over there, and both of them are coupling together, so they are kind of working together. So this take care of like the low level kind of procedural information, and then there's massive integration that is happening at the gamma band. That's roughly speaking what we're seeing in rat in the hippocampus, right? So HRM, what they did is that they took this and then they tried to replicate it like synthetically, right? And if you look at the position hierarchy into like this rat brain, you see like there's a different hierarchy. And if you look at the actual HRM, if you don't train it, there's no difference in like the hierarchy of things that they're looking at. As you train it, the hierarchy start to appear, right? But as we saw, the HRM is like the hierarchy is not that important. It's the other thing that they were doing, which is like the inference time scaling. But it maybe show there's a hint there that like there's maybe something more to explore over there. So I'm not going to dwell too much in the HRM. You can check out like the other video. The one that I've done with Julia Turk is super good. So check it out. And yeah, and we see the same thing also in human. It's not just in rat, and like in the hippocampus. So like in the human, just in the cortex, there is this sort of integration. It's a bit flipped in human. Actually, it's gamma that is doing like the low level problem solving thing. And then it's theta that is, I think is it theta or I don't remember. I think it's theta that is like doing like a more integration type of stuff, or alpha. I don't remember which one is it. But there's like interaction between the two, right? So that's the idea. So if this happens in human or in rat, and it like they're thinking and then reasoning through what the heck they should be doing, why not have this in to LLM? And maybe the LLM are already doing this. So we have a few questions. We have Gosh that says, I have a question. Why don't we train two models in hierarchical setup? One has a question generator and the other has an answer generator, similar to what's described into the Absolute Zero paper. I don't think I've read this paper, but you could do that. Yeah, definitely. Like this two system of model is already like used in multiple like actor critic kind of setup. But what they are trying to do here is not to change an architecture. That's super important, right? So in this specific paper, there's no architectural change, right? Like in the HRM, they actually literally made a new model. In this, they're not doing this. What they're saying is that your favorite LLM is actually a HRM when it's doing reasoning. And that's it. And like what you can actually see it when you kind of decouple some of these tokens. Whether you think the methodology they did was legit or not, we're gonna see it in a few. But that's kind of what they're saying, right? So it's not about like making another model completely. And also, fun fact: the HRM, like it was heavily inspired by this, right? But it's nowhere near the frequency that is similar between the two. And like this process that they base themselves upon, like it's a bit more complicated than just like these two bands and that's it. Oh, we have Agustin from Argentina. Hey man, I hope everything is good. Yeah, hope everything is good in Argentina. I have a few friends over there. All right, so before I move on to the classification of token, this is like their core method. Any other question that you might have? I think there's a lag every time like I'm asking a question, then I move on, and then people like finish typing their question, and then we're like, I have to wait and do it. Anyway, so cool. Don't hesitate to interrupt me. as I go through it. So you have two things, right? You have the definition of the high level planning token and the low level planning token. And the thing is that it's basically the high level that matters, because everything else become a low level. You see in the pipeline that they're using. So the high level planning token is like, it's like logical maneuver, right? So there's three kinds. There's deduction, stuff like we can use the fact that, right? Yeah, there's some motion of deduction. Branching, let's try a different approach. So you've went there, but now you're doing this, right? It's not actually branching, but it's like, you can say like, we went over there and now we're gonna keep that, but we're gonna staple this over here, and then technically it lies over here. So it has information about the previous branching it did. And backtracking. So we fucked up and then we come back to this and then we move like that. That's kind of the setup. It's these three that are the main ones. And the low level is like everything else: arithmetic calculation, variable substitution, direct application of known formula. They're gonna use a whole bunch of benchmark, but that's the idea. And the core element that they're using for this is what they call a strategic gram, right? Which is kind of a bucket of not just one word or one token, a bunch of tokens that means like a high level planning tokens. This is crucial. If they mess it up, then nothing like matters anymore, right? So we use n-gram because they capture the phrasal nature of strategic language. Let's consider the case, blah, 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 which is lost at the single token level. And I think they're using like 3 to 5 tokens. So it's not like big phrase. It's like 3 to 5 is usually good. And then they will be able to create this. You can see here what is a strategic gram in the current context. So let's say like this, the user asks a question and you have first I need to, this is a strategic token, but strategic gram. So I have to, even all rag sometimes is a strategic gram. Let's look at, I noticed that, let's see if, and then weight also is one, but the weight is in the backtracking category. You have the branching category here, but I'm not sure if that helped directly. Alternatively, like, and if you use a reasoning model, you see them using these things all the time, right? And this is kind of the haha moment that DeepSeek showed in our one. So that's the idea, right? And the pipeline they've done is this one. So they have a pipeline where they extract all n-gram, so 3 to 5, right here. It's the maximum. It does like a 6, 7, 8 token gram exist, maybe, right, for strategy, but they let it at 3 to 5. From a large corpus of successful reasoning solution, and then they use a sentence transformer, and then they're gonna do semantic clustering, right? So they apply a clustering algorithm to this embedding space, so this whole thing, right? Well, as it went through the sentence transformer, it goes into an embedding space, and then we're gonna group lexically diverse like n-gram together, right? To get like a bunch of bucket. So this is one thing, and then they do identification by frequency. So to identify the cluster that represent reasonable reasoning pattern, we analyze their frequency at the corpus level. They don't want to take gram that are too specific, so they're gonna remove a whole bunch of them, right? So they're gonna look at the frequency, how they appear, all of these gram in the documents that they have, which are the successful reasoning trace, and after that they're gonna filter them down, right? And then they're just gonna take the top 20%. Should we have 30? Should we have 40? Like, I don't know, right? But this is the pipeline they use. They have their code available right here, right? So you can check out like the full pipeline over there if you want to, right? Okay, so that's the thing, and it's purely data driven, but there's like a GPT. No, after that, no. So this is good. So this is like a fully data driven pipeline that is running, and you can see how it looked like, right? So this is the strategic gram. You have number of steps. A good starting point is, a more direct approach is, a more straightforward approach is, like that type of stuff, right? And you see here, a more straightforward approach, 1, 2, 3, 4, maybe is also part of that element. So there's some jitter over here. It's not like 100% like a correct. You see here you have let's, which is like multiple token. Let's analyze the possibility. Let's assume. And you have a whole bunch of them. So when they say strategic gram, this is what they mean, right? It's this whole list that they're gonna be using. So I think there's still a refinement that we can do over this methodology by like looking at this a bit more, and maybe like make one kind of data set of, yes, these are the strategic gram, like all of the permutation that there is, and you can just pull it over and then figure these out here. Maybe there's some that are missing, and maybe there's some that is like a bit more, they're more jittery. And maybe there's like also like some continuity to them. Like some are more strategic and some of them are more operational. Some of them sit in the middle. They can be used in both. I think there's more fine-grained information that we can extract from this. So if you're thinking about doing some research and you're looking for stuff, this is a good place to start, by the way, guys. If you're interested in research and you want to like have a project that actually is useful, that type of stuff is super good because you already have a pipeline, right? And now you can just kind of go and then refine something that is a bit crude, right? And then you just run the pipeline again and look at the performance, and then you have a paper that is like automatically written. So that's kind of like the a general flow to start up doing some interesting and useful research. Okay, so that's the pipeline, right? Now we get into like kind of the result section here of like what does it look like and what like metric you should be using to make sense of all this. So there's a bunch of metric that everybody knows. So you have the relative perplexity, which is the exponentiated average negative log likelihood. So basically how much surprised the model is. And then you have the token level entropy. So it's the Shannon entropy of the policy next token distribution. And you measure uncertainty. So how uncertain the model is. So as it goes down, the model is more sure of like this token that is producing. As you go up, it's a bit less sure, and there's like more change that are happening, roughly speaking, right? So the first two is this. So it's model surprise and then the token level entropy. So this is like vanilla normal stuff, right? And it's over 3 different models. So you have the Qwen 3, Qwen 2.5, and Llama 3.1, right? And then you can look at their dynamic. So the model surprise is split into 2. You have one for the planning and one for the execution token. And you can see like the model surprise for the execution token is fairly normal. It's just like, it's kind of flat. The planning token goes down a bit into perplexity and just kind of climb up afterward. It doesn't tell you much. Same thing for Qwen 2.5 and same thing for Llama. You start to notice that like these two are not the same as this Llama one, right? And you're gonna see Llama actually suck. Like roughly, it sucks a bit more than the other one. If we look at the token level entropy, it's kind of start to show a different kind of structure, where the planning tokens start high in entropy, then go low, and then go back up, because this is token level, right? It's not like the whole semantic element level. And same thing for all of them, but the entropy for execution is usually lower than everything else, right? Like this is something that is kind of true everywhere. Llama 3.1, you see them all going down. There's not this uptick here, which is a bit different, right? We have a question. Make me wonder how much noise is introduced in perplexity entropy measurement from semantically similar token, large versus big. Yeah, so that's the whole point, right? The whole point is that like just using the token is too much noise. It doesn't tell you anything. So a better way of running this is to use semantic entropy instead of like token level entropy. And they show it here, right? So this is a distribution of the tokens, right? And you see that they are dominated in terms of probability sampling by like these tokens that kind of doesn't mean anything. Like it's not semantically meaning anything that is worthwhile. And then this is the semantic entropy, the semantic distribution. Semantic entropy is computed as a Shannon entropy over the frequency distribution of n gram. So semantic gram. Intuitively, semantic entropy gather token by their semantic function and measure their semantic diversity. So that's the idea, and you can see here, goal is 2, and then this is their frequency. And here you have define the variable, and then this is their frequency, right? So this, they're saying, makes much more sense for reasoning than token level entropy, right? So like, because it actually is measuring something that reasoning model are actually doing versus like it was not happening before. Yes, exactly. They're grouping the n-gram by semantic meaning. So this is better, right? This is what they're saying. If you see it here, like you can now kind of see that reasoning kind of evolving, right? you see that there's other gram and there's strategic gram. And the strategic gram, the entropy change kind of increase over time, right? Always increasing. Versus the other gram, so things that are not like that stuff here, right? Anything that is not in this bucket is other gram, right? Even the, let's say the top 30%, so the slice that they cut off is not there. Like it's not, it's an other gram here too. And you see them like kind of going down the entropy here, right? Same thing here, you see it going down the entropy, or like staying flat, and this one like increasing. And then you see llama, and it's all messed up. Like the other gram kind of go up in entropy change and then go down and back up again. And then the strategic gram go down and back up and then down again. In terms of like which of these models is better at reasoning at the end, this one is better, this one is second best, and this one sucks. So you can see it directly from like that type of change, which is very cool. Like I find that this graph actually is one of the most useful thing, because if you have one thing to change in your pipeline is to start to measure this, because then you can be able to see a bit better how the reasoning the reasoning learning is actually happening. And then this is it, the column 2 versus 3. We compute the semantic entropy of strategic gram, the Shannon entropy of the frequency distribution of strategic gram, to quantify the diversity of the model high-level strategic plan. And the third column provides clear evidence that this strategic exploration phase. So there's two phases. There's one that is like this one, like, oh, I'm just learning about the tokens, right? And like the execution element. And then there's this other phase that is like, yeah, now I know. And then like I'll learn about the different strategies to recombine these lower level elements. And then they actually looked at the length versus accuracy, and they're very correlated together, right? And this setup, right? You can see it more and more clearly. Like here, there's correlation, but like the sequence length increased, but like not that much. Here, the sequence lengths increase dramatically, and the accuracy kind of follow, right? But these are like very connected together. And like this setup explain like the different moment, right? So here the aha moment is explained by the model kind of starting to understand like how to use these strategy level grams. And then the length scaling is consistent with increase in strategic diversity. Rise in semantic entropy of flying token is strongly correlated with an increase in average sequence length, because the strategic token will use much more like execution token, right? Because let's say if you think about it branching, like it will branch this direction and then it will be backtrack. So it will create this length, but not just by spewing out more of the tokens, it's spewing out more anchored tokens, so the strategic in gram, in order to kind of like follow a logical trace. That's roughly what's happening, they're saying. So there's three takeaway here. First, procedural constellation is marked by a sharp decrease in the perplexity and token entropy of execution token, right? So the model know how to use these kind of little building blocks, and then he has a toolbox. The model has a toolbox. The second thing is that once you have that, there's a marked by increase in semantic diversity of strategic gram, which correlate with sustained reasoning enhancement. So the accuracy is starting to go up once you have this structure. Hence, if you have a model that is already really good, and then you do reasoning, it will be even better good, right? That's the setup. If you have a model that is kind of not that great, it will have a harder time to kind of grasp these semantic elements. So, like, I don't know if you remember that, right? But like in DeepSeek R1, they tried to do their whole pipeline with GRPO and everything to make a reasoning model with a smaller model, and they were not able to do it. And it's because technically speaking, it was stuck here in consolidating its procedural element, versus the bigger model, gigantic one, already had that unlocked and could already go straight into the strategic execution type of setup. So it was learning that then. I think now we can actually make reasoning into smaller model, but like that's kind of the idea. Yeah, as to have first and foremost this structure, and then as soon as it learned to use the strategic gram, it's much better. Okay, perfect. And then the aggregate token level entropy here, they're saying, is dominated by the vast majority of low level execution token. So if you're using that as a metric, you're not going to see what you need to see, because most of the execution token have nothing to do with the strategic token. Like the strategic token are what the model is using more. Yeah, that's kind of it. Like as the model become more confident in procedural step, the entropy of these tokens decrease, pulling the global average down. Any question? Because that's kind of the whole method, right? This is it. Like there's nothing else. After that, it's just using that insight that they've gained in order to make a better GRPO. So isn't Llama 3.1b not a reasoning model since it's not trained to generate reasoning trace? Do you think it could be generated token used for more for reasoning, not captured by n-gram? I don't think, like, none of these are tuned for reasoning, right? Like these are just like the core. You see here, there's the note-take version, there's the base version, and they're trying to elicit reasoning with GRPO. That's kind of what they're trying to do. Like, but like the model is not that good. That's what they're saying. Like it is just not that great. So yeah. So generating reasoning, but in a different distribution. To be honest, I'm not sure. Maybe it's this. Like but their pipeline is kind of solid, honestly. Like it doesn't look that how's it like oh no, it could be. No, you're right. Yeah, it depends where these reasoning traces are coming from, right? So here, successful reasoning solutions, right? Large corpus of them. I think we need to double check where this is coming from, because if it comes from Quen and we just do that on Quen, like, I don't know, man, it's the kind of recycling the same thing. If they come from, like, I don't know, Llama or so, like, then there's no excuse for it. But I mean, generally what they're saying here is that, like, and what you can see is that some model are just like poorer at learning reasoning than other, even if they have like a bigger parameter count. Okay, I will have to check out their n-gram code. Yeah, you can, and basically it's over here in their GitHub. You can double check that. So now we're gonna check out how they tuned up GRPO. So we have like the base GRPO, and they're changing just a few things, right? There's nothing crazy about that. So what they wanted to do is like make kind of GRPO-like algorithm for RL that will actually elicit this more strongly. So it will bias this thing for these tokens to have a higher advantage when it's good, and lower advantage when it's lower penalty when it's not good. So they build upon your GRPO framework to allocate credit based on the reasoning hierarchy. So that's the standard advantage formulation over here, and they're changing this, right? So if this token is not part of the set of be the set of indices corresponding to planning token, we just put the normal advantage, right? If it is part of the set of the proper token for planning, we're just gonna boost it by X%, right? So we're gonna take whatever it has, and then we're gonna boost it up, and I think here it's 20%. So we're gonna take 20% of the absolute value of the advantage, and then we're gonna boost that up. It's a very crude way of doing it, but it works, right? That's the setup. So it has an amplification intensity. You can tune that up and down if you want to. They have 20% a bit everywhere. I don't know if they have a bias for this this number or something like that. Yeah. And then the successful trajectory. So if A is bigger than 0, amplify the credit for planning token, while for unsuccessful one, so when the advantage is lower, right, than the 0, so it was an unsuccessful setup, it will kind of bring its penalty up, right? So to dampen the penalty. So you see here, so if this was negative because it sucked, because of the absolute value, it will just like boost it up just a bit. Versus the other token don't have this this setup. So effectively, it's gonna push the model to output these a bit better, right? We have a question from Twitter. What do increase in semantic phrase entropy increase reasoning capability, more exploration of thought, kind of, right? Yeah, that's the whole setup, is that if you're outputting more of these, then you actually are doing reasoning. That's what they're saying, right? If you're just outputting execution token level, you're not doing reasoning really. You're just like doing one training thought. I might have missed it, but how robust is this versus how they group the n-gram for semantic? If entropy at the token level doesn't help, but entropy at the few word semantic level works, would paragraph level semantic entropy also be positively correlated, or do you think there is a maximum in semantic idea size versus entropy being positively correlated with reasoning? I think like this, what they did here is very crude, to be honest. Like you can look at it and kind of see that, like, I don't know, it's something, some of them are kind of truncated, right? And like, I don't know, like they only go from 3 to 5, right? There's maybe one word that is an anchor word for like the next step. They're using just 3 technique here. Logical deduction, branching, and backtracking. I think there's more than that. So I think like there is a play in here to have all of these reasoning kind of element, however long they are. It doesn't matter. If one is 10 word long, we should still consider it, right? And then just like jam it into a database, right? This is like one corpus of text for reasoning tokens, right? That we all agree that are reasoning. And we can maybe have scores of like, this is a high reasoning token, and this is like lower because it actually appear in other texts that are not reasoning related, right? So that's kind of what I would say. Like there's still some gains to be done because this is crude, but it works, right? That's the gist of it. So that's that. Yeah, Pareto. Maybe it's just the 20%. And then they change the resulting objective like this with the HICRA over there. They're just not showing the clipping, but it's also here. Yeah, so like that's their policy. There's just this little change. Like literally, they went in and they added a 20%. Like if you look at the methodology, it's truly fantastic. They went and they made a pipeline to classify the token into 2 things, right? And then they went and modified the GRPO code with like 1 line of code, which is using the advantage boosted for semantic token, right? And that's it. And then the rest is following from that. And they don't pre-train the model. They're just using reinforcement learning on it afterward. So compute budget-wise, it's pretty good. Like most people could run that, this type of experiment and experiment with it. It's kind of what I like with RL research with LLM is that like it's very approachable for like individual developers. And if you look at the result, Qwen 3.4b instruct, this one is the best, right? It has, well, it's generally just the best with the base, right? With GRPO, there's the boost, but with HICRA, there's even a bigger boost. You see here, 5.4% better at AIM 24, AIM 25, same thing, Math 1%, AMC 23, 1.7%, and then here, like they're very close to like almost perfect score, but still you can juice them up. Minerva and Olympiad, they're struggling a bit, but they're not that far from the baseline. So like it's pretty good, right? So this model, for some reason, like it is able to kind of understand and leverage the strategic token better. The reasoning they're giving for this in the paper is that it has a stronger operational base. It understands stuff, right? Versus the other one that are struggling have less of this. So even though this one is a 8B instruct model, it's just like not it doesn't get it, right? Like it is not improving any way. And if you look at the actual, where was I here, like dynamic of it for the strategic gram, it's all messed up. Like it seems like you need a bit more steps here to run. It's just 150 steps here versus the other one that is like 500 for this one, 150 for this one. But still, like it's like this one compared to the best one, there is a big discrepancy, like their dynamic and how it's operating. And then if you see the accuracy here, it's not even on the same scale. You have 42 here, you have 21, and then the line generalization is kind of not happening. So there's a lot of jitter over there. So that's the setup for Llama, but also Qwen 2.57b base, same thing. Like it's not crazy better than the instruct version or the adaptive node-think version here. So some models are really different, right? So if you already have a good model, it will get better. That's the setup that they're presenting. If you have a kind of an okay model, it will not improve that much. So this echo a bit like what we saw with DeepSeek, but in this case, like the size of the model is not relevant anymore. It's like what they already know, right? Qwen 3 was still trained on reasoning traces. Llama 3.1 doesn't have natively thinking. Yes, Qwen 2.5 also isn't a reasoning model. Yeah. So that's kind of the setup here. So this one is a bit dumb. This one is big brain, and you can also see it in multimodal reasoning benchmark, right? So 2.5 VL 7B instruct kind of normal-ish, but the Mimo VL instruct is much better, and it has a better, stronger base to start. So like the better model will get better with RL, which is pretty interesting. Like there's kind of like, if you are able to create a very good base, it means that you have like more emergent property to play with afterward, and like the other model can't be duct taped with RL in a significant matter, right? Cool, perfect. Qwen 3 as empty think. Okay, cool. Yeah, any other question before we go into what they learned from all of that? Because now they have something cool, right? And it's like, it looked like a bit like a free lunch right now, right? Like you could just change the GRPO for HICRA and then you're good to go. So they did a whole bunch of different stuff. First they looked at the errors, right, that were happening. Some errors, and like they had to do that with ChatGPT, I think GPT 4.0, right? They did the error analysis. So this is the instruction that they went for to evaluate, is this a logical, what was it? Is it like a planning and strategy error or like an execution error, right? So they had the model kind of like tag the two. And as you can see here, Qwen 2.5 7B base, the planning error are kind of, I think they should have normalized it into like the same kind of y-axis. But like the 2.5 are making more error and it doesn't go down, right? The 4B base and instruct, they're making less error and it does go down. And same thing here for Qwen 3, but this one is the cleanest. Like the planning error goes down and the other error also goes down as the training step are evolving. But both of them here, the training, the execution error kind of stay kind of roughly similar, right? So a model that has like these type of error going down is also correlated with like the improvement going up. And now they're justifying their semantic entropy, right? I don't know why they did that, because they already kind of did. So they show like the semantic entropy for a GRPO versus HICRA. You see HICRA as GRPO kind of stop here. HICRA can kind of go for longer, and then the entropy kind of keep increasing. And then the validation accuracy also keep increasing while GRPO is stop here. I don't know why it stopped here, but it like the GRPO is not at the same level at the HICRA for the best model. And if you look at the semantic entropy and then another type of entropy regularized loss, which they call entropy reg here, the entropy regularization baseline successfully increased token entropy. So now they're making the claim that like token entropy is just stupid, right? If you're doing RL, you should look at semantic entropy instead, right? And if you look at the entropy here and then as the step are increasing and the validation accuracy, like these two are kind of related together, but the pass at 8, which is another metric that you can use, and then the token entropy, they're kind of not, right? The pass at 8 at this point, it's kind of like similar all across, right? And you cannot see which one is better than the other one, right? Fairly connected together. Well, the semantic entropy is keep increasing and increasing. Same thing, the token entropy is all messed up. It increased here for HICRA at the end. GRPO will stay constant. HICRA entropy regularization is going down. It's kind of all mumbled. And sorry for that. And then in the Mimo VL instruct, so like the multimodal reasoning trace, you can see like the pass at 8 is just literally stops. It's saturated, right? Versus the validation accuracy kind of keep on going, even like what's it, 25 step in. So this metric means nothing. You should keep training. And the token entropy kind of means stuff, but like not that much. But the semantic entropy is a bit better. In this case, in this specific case, it goes up sharply and then you're gonna stay constant, but it goes down over here. This one goes down throughout, even though like the accuracy kind of is stopped. So the token, the end of the story here is that token level entropy is a poor metric here. We have a question over here from Lauren. Which is, Yasin, can deep learning be better than RL in artificial intelligence in the stock market? So, first off, RL is now kind of also included in deep learning because of what we're doing with LLM. So like the line is blurred. It depends what you're saying about like RL. If you're talking about like Q learning and all this stuff, RL is more like a technique that you use in machine learning context than like a branch like on its own, right? And in the stock market, I see this a lot of the time with the beginner, like can we use like deep learning to kind of predict the stock market and stuff. The issue with stock market and like these type of out of distribution, let's say, can you use deep learning to kind of forecast what new invention or what new disaster we'll have in 2026, right? The issue is that the future is way out of distribution if you look at the big aggregate, right? If you look at a very tiny slice on a very specific problem set, it's way less worse because it's not out of that much out of the distribution what's happening in the future. But the stock market is kind of very out of distribution. So usually you're gonna see like deep learning used or like machine learning, whatever, like a quant type of algorithm using very specific slice of the stock market or for a specific stock with like very specific indicator, but there's a high biases that like smart people put in terms of indicator, and then that's kind of what's up, right? So if you have a project that's trying to predict the stock market using like a massive amount of data that you have scraped or whatever, you have to understand that like it's going to be very hard, right? And other people have much more information than you. But it can be used. Yeah, definitely it can be used for a stock market prediction. So yeah, don't hesitate. If you have any question, even if we're out of the setup, it's fine. Then, like these, I like these section because that's it. Like, they're clearly made for a reviewer, right, or something. Like they like it didn't flow as neatly as the rest. But still, I think it's a good one. Basically, there is high entropy tokens, right, that already exist, and they're also called the fork token. And then, like, I don't know, maybe they get a feedback from somebody that was reviewing the paper and said, like, isn't like your semantic gram same thing as these things, the high entropy token? And they're making the claim that no, because when you actually look at it in the corpus, what they're saying is that a majority of planning token exhibit high entropy, but the reverse is not true. Most high entropy token are not planning token. So that's super important. So high entropy token is better than just token level entropy, but still it's not just about that. It's about like these specific tokens that are used in logical kind of wrestling that are important. And you see here the planning token over here, let's denote point A here. Like let's denote is a planning token, but it's not high entropy. And then you have these that are shared, let me assume, or try. It's not even let's try, it's just like try, since, right? These are a more shared token here. So that's it. They're making the claim here basically that what you should be using is these things, right? And you should calculate the entropy based on that. And if you bias your GRPO with that, it gets better in model that already have a good operational base. So that's my kind of conclusion here. The whole paper was basically just that. It's a fairly easy paper. I think like there's gonna be like multiple iteration, and I think the guys from Sapien Intelligence that made the HRM will kind of take this information and kind of make a I don't know. They may try to train a language model which not only is pre-trained, not only is post-trained with that bias, but it is pre-trained with this bias. So if it's able to be pre-trained and have like a strategic core and have another one that is like a more execution core, a bit like they did, but with another kind of structure, we might see improvement with a very, very small parameter size, right? Because like, think about it also, like here, look, we're at the point where a 4B model could do like very fantastic reasoning, right? Which was not possible just in January, right? With the Air one, it was not, just literally they couldn't do it, but now we can do it because of the way we're training it with the data, and this model can be boosted up to do even better reasoning with the HICRA. So I think like we're gonna still see like a shrinking down of like I don't know, man, like like a language model that can do super good reasoning, but that can fit in any GPU, like that is super small. And this will have a good in my view, like a good parameter count, a good performance over benchmarks. It might be longer in time for some setup, but overall I think this is where we're gonna go before the end of the year for sure. Oh, we have a new supporter. Hey GRPO, thank you very much. Very, very useful. Your $1 will be put to good use. Thank you. I really appreciate like folks that are signing up and becoming a member of the channel. Help me a lot. If I have to outsource something, I'll just use that money. Or if I have to go somewhere, I'll do that. So yeah, that's it. You can check out the HICRA algorithm in more depth in their GitHub. Fairly straightforward. And maybe you should check out the HRM, right? I think the HRM is kind of looming a bit over us still, and the guys are smart, right? They work with the NDA, the company that François Cholet created to kind of validate a bunch of stuff, kind of a consulting company. And like these guys are legit, so like I would not discredit them, even though the hierarchical module was not that important. I think like it was the first hack at it, and then they're gonna improve it on it. I'm very bullish about this front. I think their inference time scaling is important, so the time domain, but also just the idea of hierarchy of reasoning is pretty fundamental, and we see that in this paper because it's already what's happening with LLMs to some extent. Okay, we have a question. Sorry for asking a new question. Never apologize. In order to start with deep learning, should one go top down or bottom up? Ha! You know how to to trigger me. So, but like that, to be totally serious. It differs from like people to people. But what I truly believe is that if you want to learn deep learning, like to have a skill that is useful, you have to go top down. You can't go bottom up. It's just too long. Like there's just so much stuff, and like deep learning is a highly empirical field, right? So it's not like we derive everything from first principle. Like look at these guys, right? They started with like just an idea from rat brains and whatever, and then like they try it, and it actually is not working that much, the hierarchical stuff. But then next paper that look at the LLMs, it actually is working. Like so. It's very empirical. People are just trying stuff out. Like if you look at Adam W, like the optimizer versus Muon, like there is some theory behind it, but mostly just like we tried this and it's better than Armis Prop and Allegrad, right? It's like combination with the momentum, it's fine. Yeah, so like that's kind of the situation. So what I would say here is go as top level as possible, right? To the point that like if you actually want to use AI into application, like this stuff, look at this, man. Like a professional live streamer. Like go and check out the full stack path, right? And then you can already, like if you're already a web dev or whatever it is, like a software engineer, you're able to kind of understand most of this stuff and start to use AI in a meaningful manner. And then you go down. Because if you're able to use these systems properly, it's gonna be fantastic and you already have something that is useful. But if on top of that, you're able to learn a bit more, it's better. There's a book. Is it this one? Oh, just busted it. This book, right? Where am I? Here. AI engineering. This one, pretty good, right? So like this is very high level in terms of like, it's not going that deep into like a fundamental of like machine learning and what, like it just skip all of this and it starts with like the language model and like these bigger frontier model. and then it tells you like all of the different techniques, how to actually like build better and better applications. So what I would do is like screen buff first, get the high level overview. You can get that afterward to understand a bit deeper into these things. But already there, you can be a very useful kind of developer with that is using AI. You've been doing math for math. Yeah, you would have still been doing math for like a solid 5 years, right? But it's important, right? So you go top down, but you actually have to go down at some point. So let's say you don't understand GRPO and like the whole like technique behind it. It's great if you can go down and then understand a bit of the basic and then go back up, right? Because when you're gonna go back down and you're gonna study like the KL divergence and then the probability distribution, you know why you're studying this stuff. You're not studying it for the fun of it, right? You're studying for being able to grasp better all of these different techniques and the subtlety behind them. And you know when to stop. When you get it, you're like, okay, cool, perfect. You get out and then you can move on. It will make your low level learning much faster if you're going top down than if you're going bottom up. If you're going bottom up, it's like you're never gonna see the end of the tunnel. You really have to like the low level stuff in order to move fast forward. Yeah. So are you personally experimenting with HRM? Not. I'm experimenting with another architecture that I can not disclose. But the HRM, no. But I might start to play around with it because I love it so much. Honestly, I think it's a great idea, and like I would like to see more of these smaller kind of like creative architecture that kind of go against the let's throw money at the problem and just like crank it up like crazy. Because fundamentally, I believe that the transformer architecture is fantastic and how we're doing with it. But deep down, I have the feeling that like, I don't know, we're tuning up a Toyota Camry to kind of go and do F1 racing, something like that, or like freight transport, right? Like it feels like that. Like we changed this module, now it's like super messed up. You can't even understand it, but like that's what we tackle upon. I think like going back down and like try to wrestle what we've learned from the big model into like a distilled down version of the model with a structure that makes sense, theoretically, and then like scaling this up should be very cool. Yeah, I love it too. It's a good car, a very good car, right? F1 racing, freight transport. Not sure it was made for that, but like we can do a lot of things with it. Like by the way, guys, I'm not saying that the transformer is like garbage. I think it's fantastic, and I think like we still have like a solid 10 years where we're gonna juice it up like crazy. We're gonna like it will be unrecognizable. It will be very useful, but unrecognizable, and then we're gonna be very happy. But at some point, it's gonna be like, yeah, that's it. There's like 2 people that understand this, like François Chalet and like Jeremy Bernstein. That's it. Yeah, everybody else gave up, but these guys like understand this stuff. But yeah, I think like we learned a lot, right? And like there's in deep learning in general, there's like this kind of proliferation of like tweaks, right, on the model, and then there's a fundamental change that we're doing, and then it shrank down and it's become simpler. I always come back to this element, but like ResNet did that, right? You had the LSTM, you had these like highway network with like all of these, and then you have the ResNet that just like shove a residual connection, very simple to implement, and then everything was much simpler for a time. And if you look at the architecture, we still have residual connection, so we're actually learning to tweak this residual stream. So yeah, I think like we're gonna have to go down before we scale back up again. So transformer plus state space model. Yeah, state space also another thing. Fahima, I need to like chat with you about that, but that's another angle that is actually important. Okay, we have another question. How do you think comparison will be if instead of comparing to token entropy reg, they did entropy reg on the n-gram they used? That's super interesting, Caravas. I think that they haven't even like touched upon that. That will be a good experiment to run. So if you want to run this, go ahead, because you just have a small tweak to change, and then you'll be able to check it out. Yeah, guys. Like also, by the way, like that stuff, right? Like when you're down here, where am I? When you're down here in the discussion, the related work setup, like the conclusion, like that stuff that is all mushy, right? They're not even done yet. Like in research, usually like there's other ideas you wanted to try but you didn't have time, or like there's some blind spot that you had but like you didn't do it, right? So like it's perfect if you want to go and like have a crack at it and like actually do research. This is the perfect setup, because the only thing you have to do is this. You go here, right? You click on that. Ooh, and then you get to the code actually, right? You go to the code and then you look at it. You look at this and you try to figure out, oh, is this, wait, they didn't publish it? Oh no, man. Okay, they didn't release it yet. Ah, this is a bummer, man. What they didn't do it. Okay, harass them to actually release the full code of their training recipe, because like it's just the flow. Like you go there, you go look at the code, and then like you change a bunch of stuff, and now you have something that you can tackle upon, and you can just go ask them like, hey, I've done this. Like, what do you think about that? Or you publish your result in a blog post, or like you publish your result in the archive paper, and then you can kind of push a bit the frontier without having to do everything from scratch, right? Like rarely I see a good research that started from scratch. Like if a new idea usually emerge by doing some incremental work and saying something stupid like, hey, what if we tested this? And then there's a whole new area that unlocked from this stupid idea that actually worked out, right? And then this is how you get like this kind of truly novel idea. But it never is in isolation. It's always like in the process of incremental improvement. And this incremental improvement is fine. Like it's usually something simple that will have a disproportionate impact. Gotta go to. Have a great day. See you, Chris. And yeah, that's it. That's all I wanted to show, folks. Hey, Marcos. Hey, Tetsuo. Thank you for the shout out. Yeah, that's it. That's a paper. You should check it out. It's really cool. It's very simple. Print it. Go through it. And if you have any question, like don't hesitate to let me know. But it's fairly straightforward. Yeah, we're gonna start to look at more DeepSeek stuff now that the whale is awakened. Maybe later in the week. But other than that, I wish you all a fantastic rest of the week. See ya, folks.